Hello, today's presentation is all about Anode Heel Effect. To start with, let's talk about radiation production. The collision of projectile electrons from the cathode's filaments with the atoms of the anode target produces 99% heat and 1% radiation. So, this ratio of products during production, this ratio of products during radiation production can be interpreted as a very inefficient process. So radiation production is a very inefficient process. Let's talk about the anode. The anode is the positive side of the X-ray tube. Inside, you can see this is your anode, while this area is your cathode side. Your anode is designed to withstand high temperatures. It is an alloy consisting of different metallic materials, taking into consideration the three main functions of your anode. They are electrical conduction, mechanical support for the target, and for thermal dissipation. The most common materials to manufacture anode are copper, molybdenum, and graphite. So let's talk about the anode target. So the anode target is usually composed of the following elements: molybdenum, which has a melting point of 2600 degrees Celsius, rhodium, 3200 degrees Celsius, and tungsten, 3400 degrees Celsius. So tungsten has the highest among the three. So take note, you may remember it easily using the acronym MRT. Okay, next, focal spot. So the focal spot is a target area where X-rays are emitted. So for stationary focal spot, 4 mm. For rotating target, you have 1 mm. So reduce focal spot. So why do we need, or why reduce focal spot is more favorable? Because focal spot or small focal spot produce better spatial resolution of radiograph. So for diagnostic radiography, we need, or it is important to have a small focal spot. So, but the problem is, small focal spot comes with a price. No? If you want to achieve spatial or better spatial resolution, it comes with a price, and that is to hit, or we are hitting a concentrated area of the anode target. So making it at risk for the anode target to break down or to be damaged. Now, that is where your line focus principle comes into play. So line focus principle is a design of the anode. So by angling the anode target, it allows large area for heating while maintaining a small focal spot. So that is your line focus principle. So take note that this is your vertical line and that is the anode angle. So your line focus principle has an actual focal spot and effective focal spot. So what is the actual focal spot? Your actual focal spot is the actual area of the target being bombarded with electron. So this is the actual area of the target being bombarded with electron. That is the actual focal spot, which is larger than the effective focal spot using the line focus principle. So through line focus principle, the actual focal spot is always larger than the effective focal spot. So this is your effective focal spot. And what is that? Your effective focal spot is the area where your X-ray is actually being projected onto your patient or image receptor. So yun. This is the application of your line focus principle. There. Now, if you say smaller target angle, the smaller the target angle is, the smaller the effective focal spot. So, effective focal spot number 1 as compared to when the angle of your anode target is being reduced. So if the angle of your anode target is being reduced, it will result into a smaller effective focal spot. So take note that in for diagnostic X-ray tube, the target angles varies from 5 to 20 degrees. So remember, the smaller target angle, the smaller the effective focal spot. So what are the positive results of line focus principle? So, number 1, it improves or improve spatial resolution. So line focus principle results in improved spatial resolution. And at the same time, it results in increased heat capacity. While the negative result of your line focus principle is the anode heel effect. The anode heel effect is the intensity of radiation on the cathode side of X-ray field is greater than on the anode side. So take note, the intensity is increasing towards the cathode side. So this is the anode side. This is the cathode side. So towards the cathode side, the intensity of radiation is increasing. Therefore, to apply or to take advantage of the anode heel effect, to apply the anode heel effect in practice, we have to position the cathode side of the X-ray tube over the thicker anatomy. So position the cathode side of the X-ray tube over the thicker anatomy. So the following are suggestions. So application of anode heel effect. So to take radiograph of the foot, the cathode side should be on the heel. To take radiograph of the leg, the cathode side should be over the knee. For thigh radiography, the cathode side should be on the hip. Hand radiography, the cathode side should be on the wrist. Forearm, the cathode side should be on the elbow. Arm, the cathode side should be on the shoulder. For abdomen, the upper abdomen is considered to be thicker because of the presence of the diaphragm and the large liver. So remember, the liver is our largest internal organ. So that makes the upper abdomen thicker than the lower abdomen. So the upper abdomen should be on the cathode side. While for radiography of the chest, the bases where the diaphragm is located, so it should be over the under the cathode side. So the cathode side should be over the bases. Moreover, since you do not want to expose your patient's thyroid glands uh, with the cathode side, no, having the higher intensity over the anode side. So for radiation protection purposes also of the thyroid gland, you position the bases of the lungs under the cathode side. Okay, so that's all for today's presentation. And of course, don't forget to like and share and subscribe. And of course, I'd like to say thank you for your time and shout out sa mga taga UAE. Maraming salamat.